Greetings, Prof. My name is Wan Kai Jie, and this is IPPT Form, a mobile app that helps users improve their exercise form using AI and pose detection. This project uses computer vision and machine learning to track user posture in real time and determining whether each repetition is valid or invalid. So some of the motivation would be that, as we all know, the males in Singapore to do IPPT, especially the current NSF or NS men, or even the general population. And so this app can help to improve their exercise form and overall fitness. So for system overview, the solution consists of three key components: mobile Android app built with camera X and media pipe pose, a flash-based server that receives pose data and performs inference, and lastly a machine learning model trained using TensorFlow to classify valid and invalid reps. For data collection, to train the model, I first collected pose key point data using a custom Python script that used media pipe to extract 33 pose landmarks. For each exercise, sit-ups and push-ups, I recorded 10 valid and 10 invalid repetitions. These samples were labeled manually by pressing a key during recording and saved as CSV files. So 1 for invalid and 0 for 1 for valid and 0 for invalid. So in this video, this is an example of the collection of the data points where you can see the different pose points linked to the different limbs. And this is the data in a CSV format where you can see the different points X, Y, Z and visibility that should link to each limb points. When it comes to model training, the model is a simple neural network using Keras. It takes the 132-dimensional input from key points, that is 33 landmarks with X, Y, Z and visibility as seen previously, and outputs a probability score indicating if the form is valid. The model was trained locally and then exported to a .h5 file for use in a backend server. Initially, my pose classification model was built using a basic neural network with 2 hidden layers and default training settings. While it worked, the accuracy and generalization were limited. And so, to improve it, I made several key adjustments. Firstly, data splitting for validation. Instead of training on an entire dataset, I use an 80 to 20 train validation split. This allowed me to monitor how well the model generalizes to unseen data, not just the training set. Secondly, learning rate adjustment. I reduced the learning rate of the Adam optimizer to 0.0001, which slowed down the learning process but allowed the model to converge more gradually and avoid overshooting optimal weights. Epoch tuning. I increased the number of epochs to 30 to give the model more opportunities to learn, especially since the learning rate was slower. This helped achieve better accuracy over time as well. Lastly, validation monitoring. By tracking val accuracy and val loss, I could identify when the model started to overfit plateau, which was crucial in evaluating the effectiveness of my training strategy. As a result of these changes, the model showed significantly improved validation accuracy, consistently reaching 100% after just a few epochs, whereas the original model was inconsistent and overfit quickly. As you can see from the result, the val loss managed to decrease over time, while the val accuracy managed to hit 100% consistently. So for Android app integration and communication, in the Android app, I use Camera X to stream video and media pipe to track the user's pose in real time. So I tested runs on physical devices, my own tablet and mobile phone, as well as multiple users are also able to use this application simultaneously. Key points are extracted and then sent to the Plus server over HTTP every half second. The server responds with a prediction, and the app uses simple logic to detect full repetitions using the start and end posture detection. As you can see, they're calling the analyze endpoints. So for example, if valid bottom pose is followed by a valid top pose, a rep is counted. Otherwise, a warning like invalid rep is shown. As you can see here, I'm testing the counting of the repetitions for push-ups. So for online learning feature, to make the system adaptable, I added online model retraining. Users can now collect additional data by using the app and mark them as valid or invalid. This data is sent to the server, stored in a separate CSV file, and then used to retrain the model via an API endpoint, which you can see, the collect and retrain endpoints. So this requires the additional user to press the mark invalid or mark valid as well as retrain buttons. This enables continuous improvement based on real user data without retraining from scratch. And in summary, IPPT Form combines pose detection, machine learning, and mobile development to guide users toward better exercise form and get smarter over time. This project has taught me a lot about simple full-stack AI integration and working with real-time vision systems. Thank you for watching.